Most Angular applications obtain data using HTTP. The application issues an HTTP GET request to a web service. That web service retrieves the data, often using a database, and returns it to the application in an HTTP response. The application then processes that data. In this module, we begin with an introduction to observables and the reactive extensions. We then examine how to send an HTTP request and map the result to an array. We add some exception handling, and we look at how to subscribe to observables to get the data for our view. We finished the first cut of a product data service in the last module, but it still has hard-coded data. Now we'll replace that hard-coded data with HTTP calls. Let's get started. To really understand the HTTP code we're about to write in this module, it's important to understand the basics of reactive extensions and observables. So let's get technical for just a moment, and then we'll break down what all of this means. Reactive extensions for JavaScript, or RxJS, is a library for composing data using observable sequences and transforming that data using a set of operators. If you are familiar with .NET, these are similar to link operators. Angular uses reactive extensions for working with data, especially asynchronous data, such as HTTP requests, which is why we're covering it here. So what does all of this mean? Let's start with asynchronous, then cover observable sequences and operators. Synchronous communication is like a phone call. It's real time. You talk, I immediately process the information and respond. With synchronous data, the application requests a value and waits for it to arrive, like calling our getProducts method to get the list of products. Asynchronous communication doesn't expect an immediate response. When I send an email, I don't have to wait for a reply. I can do something else. When I'm notified of a reply sometime later, I can decide when to process it. From our application's point of view, HTTP requests are asynchronous. Here is an application, and here is a back-end web server. The application wants to display products, so we send a request to the web server asking for the product data. We then set up to be notified when the data is returned and continue along. At some later point in time, HTTP returns a response with the requested products, and our application notifies us that the products were returned. So this process of request and response is asynchronous. We submit a request, don't wait for it, and sometime later receive a response. In Angular, we issue the GET request using HTTP. But what do we use to set up the notifications? That's where RxJS observable sequences come in. An observable sequence, sometimes called an observable stream, or just an observable, is a collection of items over time. So it's a collection, but unlike an array, it doesn't retain items. Rather, the emitted items can be observed over time. For example, here is an array of letters. We can transverse through the letters, sort the letters, or ask for the third letter. An observable is more like this: letters arriving over time. We can't loop through them, sort them, or ask for the third letter after it's already been emitted. Think of these letters as mouse moves or button clicks, or the user typing characters. The moves or clicks or key presses occur over time. What does an observable do? An observable doesn't do anything until we subscribe. Think of a subscription like a streaming service. Until you subscribe, you won't get the latest Star Trek series. When we subscribe, the observable begins emitting notifications. There are 3 types of notifications. The most common is the next notification, which occurs when the next item is emitted, and it provides the emitted item. For example, think of tracking key presses. Each time a key is pressed, the observable emits a next notification and provides the pressed character. If an error occurs, the observable emits an error notification and provides the error information. The observable then completes, and no more items are emitted. If there are no more items to emit, the observable emits a complete notification. So that's it. Once subscribed, an observable emits next, error, or complete notifications. With that knowledge, let's revisit our prior slide with a bit more detail. To get product data for display, the code calls HTTP GET. HTTP GET returns an observable, which will emit notifications, so we'll know when the response arrives. We then subscribe to start the observable, and the GET request is sent. Recall that observables don't do anything until we subscribe. The code doesn't wait for the response, it just continues along. At some later point in time, the backend server returns a response. The observable emits a next notification, letting us know we have the data. We can then process the emitted response. Note that when using HTTP GET, the observable emits the entire response as one emitted item. So if we ask for products, the HTTP response includes the products, and the observable emits a single next notification with an array of those products. There is one more thing we can do with an observable. We can specify a pipeline of sorts, using a set of operators to transform each emitted item. In this example, when a letter is emitted, we pipe it through a fictitious lowercase operator to change its case. We then pipe it through a fictitious enlarge operator to increase its size. Observables have over 100 not fictitious built-in operators to map, filter, combine, and transform data. We've covered a lot of information, some of which may feel a bit nebulous. So let's examine how to use an observable in an Angular application and walk through a code example. A common way to use observables in an Angular application is to first start the observable with a subscribe. Then pipe each emitted item through a set of operators to modify or transform the item. Then we process the notifications from the observable. Recall the 3 notifications that an observable emits? Next, error and complete. And lastly, we stop the observable by unsubscribing. Here is some sample code to help solidify these concepts. RxJS has 2 primary packages we use to import functionality. Observable and methods we can use to create observables can be found in the RxJS package. We import the operators from RxJS operators. We use the observable creation function called range to create an observable that emits 10 numbers starting from 0, so we'll have some data to work with. We use the generic argument here to define the type of data that this observable will emit. By convention, we add a $ suffix to variables that reference an observable. This makes it easier to quickly distinguish the observables. We use the pipe method to pipe the emitted items through several operators. In this example, map and filter. We only include 2 operators here, but we can define any number of operators, separated by commas. The map operator allows us to transform each emitted item. We define the logic for the transformation using an arrow function. The arrow function parameter is the emitted item. In this example, each emitted number is multiplied by 3 and then passed on to the following operator. The filter operator decides which items to pass on and which to filter out. We define the logic for the filtering, yep, you guessed it, using an arrow function. The parameter to the arrow function is the item emitted from the prior operator. In this example, we filter the result to only the even numbers in the sequence. That is, those numbers when divided by 2 have a remainder of 0. Recall how to start the observable? Yep, we call the subscribe method. The observable then emits the range of numbers. We use an arrow function to define what we want to do with each item emitted from the pipeline. Here we simply log it. We'll talk more about the subscribe syntax and how to unsubscribe later in this module. What do you think will be logged to the console? The source emits 0. The 0 is multiplied by 3, resulting in 0. The 0 is divided by 2 with the remainder of 0, so it is included in the final result. The source emits 1. The 1 is multiplied by 3, resulting in 3. The 3 is divided by 2 with the remainder of 1, so it is not included in the final result, and so on. In the remainder of this module, we'll leverage observables to get and process data using HTTP. We often encapsulate the data access for our application into a data service that can be used by any component or other service that needs it. In the last module, we did just that, but our product data service still contains a hard-coded list of products. We instead want to send an HTTP request to get the products from a backend web server. Angular provides an HTTP service that allows us to communicate with a backend web server using the familiar HTTP request and response protocol. For example, we call the GET method of the HTTP client service, which returns an observable. When we subscribe to that observable, the HTTP client service sends a GET request to the web server. The web server response is returned to the HTTP client service, and the observable emits the next notification, providing the response. What does this look like in code? This is the product service we built in the last module. First, we specify a URL to the products on the web server. This defines where we send our HTTP requests. Note that this URL is shown for illustration purposes only and is not a real URL. Next, we add a constructor. Recall from the last course module that we use a constructor to inject dependencies. In this case, we need Angular's HTTP service, so we inject it here. And since we are strongly typing this variable to HTTP client, we import HTTP client here. Recall also from the last course module that before we can inject a service in as a dependency, we need to register that service's provider with Angular's injector. The HTTP service provider registration is done for us in the HTTP client module. To include the features of this external package in our application, we add it to the imports array of our application's Angular module, @module. Recall that the declarations array is for declaring components, directives, and pipes that belong to this module. The imports array is for pulling in external modules. Now our Angular module illustration looks like this. We declare our components, we declare the directives and pipes that those components require, and we import the external modules that we need. Going back to the product service, in getProducts, we use the injected HTTP service instance and call the get method, passing in the desired URL. We specify the expected type of response by setting the get method's generic parameter. Recall that a generic parameter allows us to define a type for the data this method works with. Since we are expecting an array of products, we set the generic parameter to iProductArray. The get method then automatically maps the response returned from the backend server to the defined type, so we don't have to. We aren't quite finished. What does our method now return? Since we are using strong typing, we should have a function return value here. We define the get method generic parameter as iProductArray. So will that be what we get back? Not quite. The HTTP GET method returns an observable, so we will receive a notification when the response returns from the backend server. Since this method returns the result of the HTTP GET, and the HTTP GET returns an observable, our method returns an observable. Because we told the HTTP client service to map the response to an array of product, our observable emits that array of products. We indicate that with the generic parameter. So our getProducts no longer returns an array of products. Instead, it returns an observable that will emit an array of products when the response is returned from the web server. Will this code then send the HTTP GET request? Nope. Any idea why? This code returns an observable, and that observable won't do anything until we subscribe. We'll talk about subscribe in a few moments. For now, let's set up our HTTP request in our product service. In this demo, we'll set up an HTTP request to get the products for our product list page. We are looking at our application's Angular module we called App Module. Recall from the slides that Angular registers its HTTP service provider in an Angular module called HTTP Client Module. In our application's Angular module, we import that HTTP Client Module. We then pull that module into our application by adding HTTP Client Module to the imports array here. Now we can inject the Angular HTTP service into any class that needs it. Here is the product data service we created in the last module, with all of the hard-coded data. We want to modify our product service to get the product data using HTTP. We want Angular to provide us an instance of the HTTP client service, so we identify it as a dependency in the constructor. We don't have a constructor yet, so let's add that first. Then we specify the parameter and add the import statement. Angular will then inject the HTTP client service instance into this variable. We need to identify the URL of the web server that we'll use to send the HTTP requests. We'll define a private property for that purpose. This doesn't look like a valid URL to a web server. To keep things simple, the demonstration reads the data from a local JSON file that was provided with the starter files. That way, we don't need to set up an actual web server. However, we do need to define the location of this JSON file so that the Angular CLI can find it when it serves up the application. I've already done this in the provided starter files. Here in the angular.json file, we can see the path here in the assets array. To change this code to work against a web server, simply change this URL to point to an appropriate web server. And of course, you need to write the server-side code to return the list of products. It's finally time to delete our hard-coded data. So let's delete the hard-coded products from the getProducts method. Gone. We'll call the HTTP get method here instead, passing in the defined URL. We set the get method generic parameter to iProductArray. When we get a response back, this method will then automatically map the returned response to an array of products. We'll need to change the return type as well. Now this method returns an observable of iProductArray. And add the import statement. We can't try this out at this point because we are not yet subscribing to the observable returned from this service. Plus, looking at the console, we have a syntax error where we are calling this method since we changed the return type. Let's add some exception handling first, then modify the product list component to subscribe to the observable list of products. As you can imagine, there are many things that can go wrong when communicating with a back-end service. Everything from an invalid request to a lost connection. So let's add some exception handling. There are two key observable operators that we'll need. Tap taps into the observable stream and allows us to look at the emitted values in the stream without transforming the stream. So tap is great to use for debugging or logging. Catch error catches any error. We import them both from RxJS operators. As we discussed earlier in this course, to use these operators, we access the pipe method of the observable. We then pass in the operators, separated by commas. Here, the tap operator logs the retrieved data to the console. That way we can verify it's been retrieved correctly. And the catch error operator takes in an error handling method. The error handling method gets one parameter, the error response object. In the error handling method, we can handle the error as appropriate. We can send the error information to a remote logging infrastructure or throw an error to the calling code. Now let's add exception handling to our product service. We are back in the editor with the product service just as we left it. This code is not really complete without the exception handling, so we'll add the appropriate imports for both the catch error and tap operators. Recall that HTTP GET returns an observable. We call the observable's pipe method to specify a set of operators. First, the tap operator to access the emitted item without modifying it. The tap operator takes in an arrow function. The parameter is the emitted data, and the function defines what we want to do with that data. In this case, we log it to the console. Here we use JSON stringify. JSON stringify is a JavaScript method that converts an object or array of objects to a JSON string. This makes it easier to display in the console. We want to add a second operator, so we insert a comma, then the catch error operator. The catch error also takes in a function, but this time we'll pass in a named function, or named method, instead of an arrow function. I'll paste in the handle error method, and we need the import for HTTP error response and throw error. In this method, we handle logging our errors any way we want. For our sample application, we'll just log to the console and throw an error to the calling code. So our getProducts method is complete. We can add other methods here to post or put data as well. But we still have that syntax error here. And we can't see the result of our hard work because we are not yet subscribing to the observable. Let's do that next. Observables are lazy. Just like a newspaper or newsletter, an observable doesn't emit values until we subscribe. So when we are ready to start receiving values in our component, we call subscribe. The subscribe method takes an optional argument, which is an observer object. As its name suggests, the observer object observes the stream and responds to three types of notifications: next, error, and complete. We use the observer object to define handler functions that execute on these notifications. The first handler function is often called a next function because it processes the next emitted value. Since observables can handle multiple values over time, the next function is called for each value the observable emits. The second is an error handler function. And, yep, you guessed it, it executes if there is an error. In some cases, we want to know when the observable completes, so observables provide a third handler that is executed on completion. The subscribe function returns a subscription. We use that subscription to call unsubscribe and cancel the subscription if needed. Now that our product data service is returning an observable, any class that needs product data, such as our product list component, can call our service and subscribe to the returned observable. This line of code calls the product data service getProducts method, and because we subscribed, it kicks off the HTTP GET request. It then asynchronously receives data and notifications from the observable. We pass an observer object to the subscribe. This syntax defines a key and value pair, where the key is the function name and the value is the function, specified here using arrow function syntax. The first observer function specifies the action to take whenever the observable emits an item. The method parameter is that emitted item. Since HTTP calls are single async operations, only one item is emitted, which is the HTTP response object that was mapped to our product array in the service. So the parameter is our array of products. This code then sets the local products property to the returned array of products. The second function is executed if the observable fails. In this example, it sets a local error message variable to the returned error. A third function, not used here, specifies the action to take when the observable ends with a completed notification. The third function is rarely used when working with HTTP requests, since they automatically complete after emitting the single response. It's good practice to always unsubscribe from any observable we subscribe to. There are several ways to unsubscribe. Here's one. First, store the observable subscription in a variable. Then implement the onDestroy lifecycle hook that's executed when the component is removed from the display and destroyed. Lastly, use the subscription variable to unsubscribe. In the ng-on-init, we assign the observable subscription to a variable, then use that variable in the ng-on-destroy to unsubscribe. Now let's subscribe to and unsubscribe from our observable. In this demo, we modify our component to subscribe to the observable provided by the product service. And when the component is destroyed, we unsubscribe from the observable. Here in the product list component, we see a syntax error. Now that we've changed the product service getProducts method to return an observable, we can't assign the result of our product property directly. Rather, we subscribe to the returned observable. We call the subscribe method, passing in an observer object. The observer object provides functions for responding to our 3 notifications. Recall what those notifications are? Next, error and complete. For the next notification, we define an arrow function to specify what we want to do when the observable emits the next value. And since this is an HTTP request, it only emits one time. When the array of products is returned in the response, we want to assign our local products variable to the returned array of products. But things don't always go as expected. To handle any errors, let's add an error message property. We'll add it up here by our other properties. Then back down to the subscribe, add a comma, then we use the error notification to define what to do if the observable emits an error. In our case, we'll assign our local error message property to the provided error string. Are we ready to try it out? Oh, we have no data. Why is that? Let's look again at our code. From the point of view of our application, HTTP is an asynchronous operation. What does that mean exactly for this code? Let's take it by the numbers. Angular first initializes the component and executes the ng-on-init method. We call the getProducts method of the product service. The product service returns an observable of iProduct array. We subscribe to that observable, and the HTTP GET request is submitted. This is the asynchronous operation. This code is then complete, and we execute the next line, which is setting our filtered products. But at this point, our products property is not yet set, so the filtered products is empty, and we see no data. At some future point in time, the service receives the HTTP response from our request. The response data is mapped to an array of products. The response is piped through any operators, and the observable emits that map data to any subscribers. Our subscriber receives the emitted data and assigns our product property to the emitted array of products. But since we are binding to the filtered products property, we are not notified that we now have the retrieved list of products. There are several ways we can handle this. One option is that we can move this line into the subscribe function. That way we won't assign the filtered products until the retrieved set of products are emitted from the service. Right now is a single-line function. To pass in a multiple-line function, we need to add curly braces, like this. And let's not forget the semicolon. Now that it's a multi-line function, we need to end each statement with a semicolon. Then we can move this line into the function. Now this line is executed after the products property is set to our list of products. Let's check it out. There are all of our products. Success! We have more here now because we are retrieving the products from the provided product.json file. If we open the developer tools, we see the data logged to the console here. Now that we have the subscribe working, let's be sure to unsubscribe. Back in the code, in the product list component, implement the onDestroy lifecycle hook by adding it to the implements here. And add the import statement. Then let's declare a variable for the subscription. We'll call it sub. It's of type subscription, and we need the import statement. Now we have a problem here. You may recall at the very beginning of this course, we talked about setting up our project to use TypeScript strict checking. That means we can't declare a variable without assigning it a default value. Let's look at our options. We can allow the variable to be undefined. This sets the data type of our variable to subscription or undefined. So we could handle it that way. Undoing that, alternatively, we can define a TypeScript definite assignment assertion. The bang or exclamation point tells the TypeScript compiler that we will handle the assignment of this property sometime later. Since we plan to assign this variable in the ng-on-init, let's go with this option. In the ng-on-init method, we assign the variable we just created to the subscription returned when calling the subscribe method. We then define the ng-on-destroy method that's required by the onDestroy lifecycle hook, and use the subscribe variable to call unsubscribe. Let's check it out to ensure it's all still working. Looking good. The recommended way to use HTTP is to encapsulate it in a service, like our product service, then expose an observable for use by any component that needs product data. The component simply subscribes to the observable, and at some later point in time gets the data or a notification. Let's finish up this module with some checklists we can use as we work with HTTP. Before we can use Angular's HTTP client service, some setup is required. We need to ensure that the service provider is registered with the Angular injector. This registration is done for us in the HTTP client module. So all we need to do is pull the HTTP client module into our application. We do this by adding HTTP client module to the imports array of one of our application's Angular modules. Build a data access service to wrap HTTP requests. In that data service, define a dependency for the Angular HTTP client service using a constructor parameter. Create a method for each HTTP request. In the method, call the desired HTTP method, such as GET, and pass in the URL to the desired server. Use generics to specify the response return type. This will transform the raw HTTP response to the specified type. Add error handling in the service as desired using the catch error operator. In any component that needs data from a data service, call the subscribe method to subscribe to the observable. Provide a function to execute when the observable emits an item. This often assigns a property to the returned data, and if that property is bound to a template, the retrieved data appears in the view. And add an error function to handle any returned errors. The component should unsubscribe from any observable it subscribes to, store the subscription in a variable, implement the onDestroy lifecycle hook, and use the subscription variable in the ng-onDestroy method to unsubscribe. Here are some related courses in the Pluralsight library. To perform create, read, update, and delete, or CRUD operations using HTTP, see the Angular Reactive Forms course. It demonstrates how to display, edit, and save data in Angular. For more information on RxJS and observables, see the RxJS and Angular Reactive Development course. It provides a detailed look at observables, including how to combine data from multiple sources, build action streams to react to user actions, and work with streams without subscribing. See the Angular HTTP communication course for intermediate HTTP techniques, such as error handling, building interceptors, and testing HTTP requests. We've now removed the hard-coded data from the product data service, yay, and instead retrieved the data using HTTP. In our sample application, we are using HTTP to retrieve the data from a local JSON file, but the techniques are the same for retrieving data from a backend service. Next up, we'll see how to display multiple pages with navigation and routing.